Hi, everybody. I'll do a quick introduce of myself. So we're going to have some fun together. We're going to try to build and run and secure and manage generative AI application from scratch. So I will show you generative AI application I built as part of the wave of learning generative AI, as part of the wave of using ChatGPT every day. How many of you actually use ChatGPT almost every day? Wow, only a few of you. I would expect a little bit more. Okay, cool. So as part of that, I decided the best way to learn is actually build something myself. So I want to share with you all the journey of myself building generative AI application and how do I deploy and how do I run it in Kubernetes and how do I secure the application. So this is going to be a very interactive session. I have to confess, I'm showing you something some of the steps I haven't really practiced a lot myself. So there may be some hip hop, so let's do it together. A little bit of introduction about myself. My name is Lin Sang. I work for a small company, Solo.io. How many of you heard of a small company? All right, 2 of you, thank you. So 3, thank you. I'm the head of open source at Solo.io. I feel like I have some of the best job I had in my entire career, that I spend most of the time working with open source, talking to open source community, being the maintainer for some of the cool projects, which I will show you as well. So very exciting time. We're going to be mostly about demo, as I mentioned. So we're going to show you a couple of things. So first of all, we're going to do some Python code review together to show you the generative AI application I built. And it's a web application, so I use Streamlight to power the web application. And I talked about earlier, I'm running Kubernetes. How many of you are familiar with Kubernetes? All right, awesome. And I'm going to use kind on my cluster, which is one of the most simple way to run Kubernetes. We're going to also using Istio to secure the communication between microservices. And I'm going to using Istio Ambient Mesh, which is the new mode we introduced in Istio without running sidecars. And we're going to use a dashboard to help us visualize the application. So the dashboard is called Kiali, and how the dashboard is generated is through metrics collected by Prometheus. And we're going to use K9s to visualize the Kubernetes cluster, the pods, the services, and the resources. I'm using Flannel as the CNI. And I'm using Spiffy to assign identity for the pods. And this is all managed by Istio. And I'm using Argo to push some of my application into my Kubernetes cluster. For large language model, I decided to run most of the stuff locally using a Llama. So I have a couple of large language models loaded into my local Llama. For those of you who are not familiar with Llama, one thing I really love about it is you can run large language models with a Llama as a Docker container locally on your laptop. So it's very, very powerful. And then we're going to use Kubernetes Gateway API, which is the future of Kubernetes networking API. It's effectively is replacing the legacy Kubernetes Ingress API out there. And we're going to have a little bit of fun with a new project called K-Agent, which I'm going to ask K-Agent to help me to do some of the tasks I'm going to do. So that's really a quick overview of the demo. And the repository is out there in case you're interested towards the end of the talk. All right, so let's show you guys my Kubernetes cluster. I have a bunch of things already installed. I have Argo already installed. I have Istio also installed. I have Kiali, which is the dashboard, Prometheus. I have K-Agent installed, and you can see it's a kind cluster. So pretty much what I described to you, right? And I have the code right here. So let's review the code really quickly. Let me close this one out. So the application I built, I really didn't give a fancy name. So it's called demo application. And I decided to use in Python because most of the generative AI stuff application are using Python. And when you deal with Python, you have to specify the dependency. So that's what the requirements.txt file is for. So let's review the code really simple. It actually is have a landing page. So I'm using Streamline to build the web application. So this is the version 2 of the application for the demo app. And essentially it's saying you select a demo from the sidebar to see some of the demo examples. Examples I want to show you today, I actually build more examples than what I want to show you, but I'm going to just focus on show you a couple of ones that we're going to work I'm going to demo to you. So in the first one is chat with Llama. By the way, let me quickly show you my Llama running my local environment. So this is how the Llama is running locally. You can see I can quit, I can restart to update, and I can do a list command. And this shows you the large language model I loaded on my laptop into a Llama so that I can call them outside. They are running outside of my Kubernetes cluster as Docker containers. So the models we're going to use is Llama 3.2. It handles conversation style of chat. And the other model we're going to use is called Nava, which can analyze a picture and kind of describe what's in the picture and can help us analyze the mood of the picture. So these are the 2 large language models we're going to use together. Just to show you the application chat with Llama, it's actually really, really simple. Well, I config, where is my Llama-based URL. In this case, I'm running on local host outside of my Kubernetes cluster, and I'm running on the default port which Llama listens to. And this is the title of my page. And in this case, I'm constructing my messages, which I specify the role and the content. That's going to print it out to the user. And then the user would enter chat input as part of the session. And then we're going to initialize the Llama client. And then based on the user's input of the chat, we're going to send the Llama client, which we specify in the model. Remember, we have more than one model loaded. And then as part of the messages, we're going to capture the messages from the user and ask Llama, hey, can you send output based on this particular messages, and we specify not to stream the response in this example. And when we get the response back from Llama, we're going to append the chat messages and write the messages out. So that's a really simple example. The other example I want to show you is the analyze mood, which is very similar as the chat. But this one is kind of fun that we can analyze an image for the mood with Nava, which is the other model. As you can see, we gave a title like the previous one, and we use this Streamlight function to be able to capture the images from either my laptop or my phone. And then we're going to send a prompt to the large language model with this message to say, hey, I'm a user, can you analyze the image and describe the mood and anything unusual, and this is the images we're going to send to you. And then we're going to send, use the llama.chat function, the same function, except we specify a different model in this example, and then we're going to write the stream back. So these are the 2 pages we went through. So let's show it, let's get it running together. So the first thing I'm going to do is I need to, you guys all know how to build stuff with Docker, right? Yes? All right, so I'm going to skip that. So essentially, I have a Docker file, so you can run, okay, so go to not allow. So you can run Docker build to build this demo application. And then what I did was I pushed the demo application into my own GitHub repository so that I can consume it using Kubernetes pods and services. So for instance, this is the demo application. And you can see I created a service account for the demo application. I put a service out for the demo application. It's listening on port 80 and targeting port 8001. As far as the deployment, it's this, this is the images that I would build out of the Docker file and then push to my Docker registry. And then I specify what is the Llama-based URL, which points to my local Llama on port 11434. And then I specify my update strategy. So with that, let's go ahead specify, push this to my Kubernetes cluster. So in order for us to do that, we're going to use Argo. So we're going to call this Generative AI demo. And as far as the project, I'm going to use, I think there is a GitHub location. So we're going to specify sync as manual because that way we can make sure the content is synced. And then we're going to put to the head. And the folder I believe we just reviewed together is the Kubernetes folder. All right, so we're going to do that path as the path we want to sync. As far as the destination cluster URL, I'm going to point to my local Kubernetes cluster, and I'm going to go ahead to deploy it in the default namespace because that's the easiest namespace to work with. I think that's it. So let me go ahead and create this Argo application. And I'm going to click on the sync button because we specified to manually sync the changes from, all right, looks like it's synced. All right, so we should be able to see our application running here. All right, as you can see, I'm not lying. So it does, it was just deployed 14 seconds ago, right? So it deployed the demo application we reviewed together. It also deployed a client application, which we're probably not going to use it. And also it deploys a RAG version 1 and version 2. If we have time, we will go through that as well. All right, so but let's show how the demo application works. So in order for us to view the demo application, one thing we need to do is we can set up port forwarding, which should work, hopefully, but this is not a good way. This is only a way to test it locally. So you can see that's the chat I just showed you, right? Chat with Nama on anything. So we can say what are fun things to do in Denver. If I spell correctly, is that correct, Denver? All right, so this is what I was talking about. The bot would say, how can I help you? If you remember what code, we look at together, and then we would, the bot would, based on the user's input, and put the response back from their large language model, which is a Llama here with Ollama 3.2 or 3.3, and then show the user the response, right? So all this makes sense based on what we reviewed together. All right, the next thing I want to show is analyze the mood, but in order for us to show that, we can analyze the mood now, but I thought it might be good to access the application through an ingress gateway, right? Because typically, you don't port forward in your application directly outside of your cluster, and you use a gateway to control traffic into your cluster. You use a gateway to control the traffic from inside of your cluster going outside to an external service like maybe some Amazon storage, S3 storage service, or you use a gateway to control traffic inside of your cluster. So with that, what I'm going to do is I'm going to disable the port forwarding here, port forwarding, if that's the right command, and I think it's Control D. All right, so I'm going to disable that, and I'm going to try to deploy ingress gateway. So to deploy an ingress gateway to control the traffic, let's see, I think I have ingress gateway YAML here. So we're going to deploy ingress gateway, and we're going to, by the way, this is using standard Kubernetes Gateway API, and I'm going to deploy it using the cluster name of Istio. So if you're using a different gateway, you can just specify a different class name as long as they implement the Gateway API. And then I'm going to specify a listener on port 80. And when the traffic comes to port 80, by the way, you can do HTTPS as well. But for simplicity, I'm just showing HTTP in this case. So I don't have to set up like the keys and certificates, which are all set upable. All right, so what we're going to do is we're going to deploy this ingress gateway into the Kubernetes cluster by copy this into the folder. I think I got it. Is it git-p? Okay, I guess it's git-a. Dot. Okay, add ingress gateway. All right, so that should add the ingress gateway here. So that should, but that doesn't configure the route. So when the traffic goes through the ingress gateway, it doesn't know what to do, right? So in order for the gateway to figure out where the traffic should go next, when its traffic arrives on port 80, you also need to configure a HTTP route. And I have a simple HTTP route demo application here. So for this one, it essentially says, when the traffic goes to the gateway on /pass/, let's go ahead forward to the demo application on port 88. So let's go ahead deploy this too. So copy policy is the demo HTTP route to Kubernetes. All right, so let me add this one in, and then that's ingress route. All right, so we have this all checked into our GitHub repository. I'm going to do a sync command here, and let's see if it works. All right, so right now, if I go here, you can see the ingress gateway is deployed. By the way, it was 16 seconds ago, so that's what the Argo did it for me, right? The moment I pressed the sync button, Argo was able to push the changes to the cluster. So I'm going to try to forward this to a different port number so that we can try to access the ingress gateway. All right, so now if we go to localhost 888, all right, we are getting a problem with the site. So apparently there is an error that we need to troubleshooting. And what I'm going to do is, and this is a little bit wired, so I'm going to ask agent project to help us troubleshooting. K-Agent is a new CNCF sandbox project that provides a bunch of agents. And the agents I'm going to use is called AI Reliability Engineer Agent. And finger crossed the agent can help us figure out what's going on. So I'm going to specify a debug live session, because and then I'm going to ask the agent, hey, my demo service in the default namespace is not reachable from Istio ingress gateway. Can you help me debug it? All right, do you agree that's the problem? Yes? All right, so I'm gonna hit enter and see if the agent can actually do the work for us. If not, I will have to figure out manually myself. All right, so the agent says there's so many things can go wrong with anything with Kubernetes, right? So, but the agent, I think it's on a good track, right? Make sure the ingress is running, make sure the demo service is running, and make sure the Istio configuration, which by the way, I'm not using Istio virtual service, I'm using the gateway and HTTP route. So I want to give agent a hint. So the agent asked me, what is the name? The name of demo service is demo. I'm using HTTP route instead of virtual service. All right, so I'm going to give a little bit of hint based on what I know and see if the agent can figure it out. All right, looks like the agent was able to determine at least the Istio ingress gateway pods are running and ready. The demo service exists in the default namespace and has endpoints ready. The HTTP route resource should route traffic correctly, and the gateway is configured properly. There's no network policy that blocks traffic. Wow, that's pretty cool if you can validate all these. All right, I guess the agent executed faster than I can read. All right, so the agent is review the HTTP route and gateway resource related to the demo service and analyze the configuration now. Okay, thankfully it presents a summary to us, so that's all we have time to read. All right, so it says the demo service shows targeting port 80001. This means your service is on port 80. That sounds right. There are no HTTP means route. This means your demo service is not reachable. That's interesting. I didn't see. Okay, so it hints me the service port should be 80. Confirm and okay. So the service port. Let's double check. What is our demo service port? If you go here, the demo service port is 80. The target is 80001. Okay, but I'm a little bit worried. It doesn't find any HTTP route. Let me see if I have any HTTP route deployed. I thought I do. Okay, so maybe I didn't. Let me double check what is going on. I thought I had the demo HTTP route loaded here, but maybe I had a GitHub issue that I forgot to push the code. Oh, I did forgot to push. Remember, I commit the code, I didn't push it. Oh my gosh, that was unstaged for sure. Okay, so I have the HTTP route here now, and what I'm going to do is press the sync button. Okay. All right, it's synced now, so the HTTP route should show up here. Okay, I'm going to ask the agent. Thank you for, I just deployed the HTTP route. Actually, let me see if it works now. Okay, still didn't work, so. Yeah, different error though, so I think we're making progress. Can you continue to debug? If this works, finger crossed. But the agent was helpful, right? At least helped me troubleshooting. Oh gosh, I forgot to commit and push the changes. All right, let's see. Please confirm the namespace you deploy the HTTP route, the default namespace. Okay. All right, let's see. All right, I think the agent actually have a critical observation. The HTTP route backend port is 8080, but your demo service targeting port is 8001. So the ingress gateway and confirm the port of your demo should be exposed. It should be exposed on 80 if I remember correctly, right? Because we look at here, the target port is 8001, but the port of the service is actually 80. So the agent is not super smart, unfortunately. But they did say fix the demo service or the HTTP route backend port to match. So the agent, I think it figures out what to do. Yes, please locate the GitHub repo based on the Argo application. So let's see if the agent can help us figure this out. Okay, I will create a branch. So to fix the port matching the demo service endpoint, but I don't think this is right. I think the semantics the agent was trying to do is correct to get the ports corrected, but I don't think it handles the port correctly. Because the ports here, if I look at it correctly, should be 80, right? Because the part of the ports is 8001, but the service port is 80. So let's actually see if I search. Yes, the backend is on 80. Oh, that's because the routes here. Because that routes we review together, here is 8080. That's what the agent was saying. So this one should map the demo service port number here. Unfortunately, it doesn't match right now, which is why we're getting the 500. I think they have, it has the right hint based on my understanding of the application. So let's see, I searched under but didn't find a file exactly called, that's odd. I will now search for demo paths in the Kubernetes. That's interesting, they couldn't find a file. Can you find it in the Kubernetes paths and update the demo HTTP route to use demo service on port 80? I think that's it, port 80. All right, let's see if the agent can do this. All right, so now it's searching the repository for this file, names So what's a little bit challenging right now is I want to make sure it's searching the Kubernetes folder because I also have a policy folder. If you remember, I copied the file over to the Kubernetes folder. So I want to make sure the agent is making the changes in the right file. I want to make sure agent is looking at the right file first of all, and then hopefully they're proposing changes to the right file. But it's on me making it a little bit more complex for the agent to figure out, with both of the folders have similar contents. All right. Let's see if it finds it. All right, the backend port is 8080, but I will create a branch. All right, it looks like the agent figured it out. And change this to 80 and commit update, create the pull request. And all right, to confirm, I will retrieve the full content. All right, I have fetched the content. I now update it to 80. All right, looks like it created the branch. All right, I think agent, unfortunately, I didn't give the agent permission to create a branch. So this is on me. Actually, let me see if I can fix this live, if I know how to fix this live. All right, so if I go to here, and if I can invite, password, that's the hardest thing. All right, I have to give up. I don't want to show my password. But apparently, I think the agent figured out what to do, and it was trying to create the branch for us. Let's see if the branch, the branch didn't get created, as you can tell. And but the good thing is, the agent is trying to update the port to 80 in the HTTP route manifest. So let's fix that manually, and I will fix the agent permission issue offline because it requires my GitHub credential, and I don't remember my credential. I have to pull out my password, then everybody will see my password. So it's bad on me, but I do think the agent seems to have a good hint on what's going on here. All right, so in order for us to fix that, let's change this to port 80 so we can do a match on the port. And with that change, let's go back to git add -p, yes, and Let's do a commit, fix port, git push. All right, so we did push this time, and we're going to click on the sync button, and we should be able to see the HTTP route, the new one pushed. Let's double check it's pushed. So this is the one we just pushed, and you can see it's on port 80. By the way, one thing I love about the new Gateway API and HTTP route is you have really nice status. So I didn't show you this earlier. I bet you when the port was wrong, it would actually flag there was a problem with the route, which is super helpful for debugging. And that may be what the agent was relying on to debugging in addition to logs and everything too. So finger crossed, if we go here, yes? All right, it did work. Okay, how much time do I have? I think I have 2 minutes. All right, let's see if we can analyze the mood now. Trying to get this thing working. So what this thing is going to do, if it works, it should be able to connect to my phone. All right, I'm going to hit on allow. All right. Sorry, I wasn't fast enough. Let me try one more time. You know, Bluetooth sometimes is very, very fragile. But there we go. Yes? Are you guys ready to analyze the mood? Yes? Yes? All right, show your sound mood, please. All right, yes? All right, so what's going to happen? Remember we reviewed the code together, right? It's going to send this picture I captured on my screen through my phone. And it's going to send to this model. It's called Lava, which is running locally on my machine outside of my Kubernetes cluster. And it appears to be, analyze the images. Okay, you guys are attendees of a presentation, modern, minimalist design, blue carpet. All right, there's a stage and podium in front of the room. The mood seems to be one of anticipation or concentration, and focused ahead, waiting for a speaker or event to begin. Okay, cool. I think this is pretty accurate of you all trying to figure out what's next, right? Do you agree? Yes? All right. There's nothing unusual about the image, which I agree. It's typical conferences, the audience is in diverse age and gender, which is common for such events. All right, so that is the application I want to show you. So just quickly recap here. So what we did together is we reviewed the code for the demo application. We were able to run the code in Kubernetes cluster. We were able to ask a fun question, what are the fun things to do in Denver? And then we were able to deploy an ingress gateway to control the traffic into the demo application through the ingress gateway. And we had a little bit hiccup with, first we forgot to deploy the route configuration, push to production. Second of all, there was a port mismatch. And we asked the agent to help out. Do you think the agent was somewhat helpful? Yes? Yes, even though not 100% helpful, maybe not replace a human, but it's a free resource sitting on your side as another pair of eyes. So I think it's pretty cool. So we have like 5 minutes left. I'm going to pause a little bit for any questions you all may have. I mean, certainly I have way more content because I also develop a RAG demo because what I discover as I go through the learning journey is when I ask the large language model, sometimes it doesn't know some of the stuff I'm asking. So RAG is very good at to provide like domain-specific knowledge. So the RAG model I have allows me to drag my own contents, and I can upload to a vector database, which I'm running ChromaDB as part of the RAG services here. And then I can ask questions regarding the documents I uploaded through natural languages. So, but I won't pause here before I talk about that, because we only have 6 minutes left to see if anybody have any questions so far. Yes?
The K-agent instance you had, was that pointing at one of the local models?
That's a great question. Yeah, let me show you. So that's a good question. That means you are really paying attention, so good job. So first of all, I'm going to go back to K-agent here, just show you I have K-agent running, right? So one thing interesting with K-agent is there are customer resources with K-agent. So you can see this is the AI reliability agent that I was showing you all, and it's a YAML format. So the way to run the agent is you configure it declaratively. I actually didn't develop this agent myself. One of my coworkers developed this agent, and I just took it, the YAML, and run it on my environment. So you can see this agent allows you to configure, what is the scale of the agent, and what are the things the agent can do, and you can describe what's the description, what's the model config of the agent, which I'm using the default model, which is ChatGPT 4. I'll show you shortly as well. You can also figure out what is the system prompt for this particular agent. So for instance, for this particular agent, you can specify what are the core capabilities, what are the operation guidelines. I know we don't trust the AI to do things. For this agent, we specifically ask, when you see things that doesn't work, go ahead, propose a change as a PR, but don't make any changes to my cluster directly. So that can all be put into the instruction of the agent. So that's what I was talking about. Unfortunately, it was my bad because I was showing the AI reliability agent with a different repo, and I forgot to give the agent permission to this particular repo, which is why you saw that permission error. So back to your question, I think it's called model config. So you can see what are the models I configured. So I have two models. One is the default model, which is using OpenAI. The other one is using a Llama. So you can see in this one, I have the GPT 4.1 mini. So a long way hopefully answers your question. Yeah? Okay, cool. You have a good question?
You were interacting with the agent in the command line?
Yes. That's a good question. If I understand the question is, do you mind if I repeat it? Because the distance, I think your question is, I was using K-agent using a command line. Is there a way to pump the output of the agent somehow to an external system? Is that the question? Is there a way to interact the agent with the CRD or? That's a great question. So you can't really interact with the agent with just the CRD. So basically, the CRD allows you to give instructions of the agent on what to do. But we do have a dashboard. Let me show you quickly. I think you would be interested since you're asking on this topic here. So this is the AI reliability engineer. By the way, just to show you guys quickly here, this is the dashboard of K-agent. You can use config MCP, model context protocol. You guys probably heard a lot this week. You can consume MCP server directly. In this case, I don't know how to interact with GitHub. I don't want to spend time to create tools how to interact with GitHub. So what I did was I just added a tool server for the official GitHub MCP, which allows me to create an issue, create a branch, create or update files, create pull requests. If my permission worked, I will be able to show you. So that's the great thing about the MCP ecosystem. And if you look at my agents here, this is the AI reliability agent, and this debug live, remember, is the one we did together. So, sorry, this is a little bit hard to see. And you can see it shows on the right side, it shows all the tools I'm using. So a bunch of the tools are from the GitHub MCP server. Some of the tools are some of the Kubernetes tools, such as like get pods, execute command, describe resources, get events to help us troubleshooting. And all the conversation here is actually recorded. I know we didn't have time to look at everything the agent says. I mean, I think the agent says way more than me, hopefully. So, but you can see from my first ask of the agent, and the agent is trying to tell us, what's going on. Everything is there. I don't think we have a direct way to export it out, but we could potentially look into that. It shouldn't be very hard because we already saved that data that you can retrieve from the UI as well. Does that answer your question, hopefully? All right, I think we're out of time. Maybe one more question. I don't want to hold out other people up.
So if you go back to like where you were doing your RAG implementation,
yeah.
Have you played with this to the point that I guess you would just give it your entire tech stack and all the associated documentation for everything you're integrating and the associated like charts, the whole thing. How well does it actually behave then?
That's a great question. I can't say this RAG module I developed is very well performed. It can take PDF or TXT. I developed the first version. It can only take the PDF files. The second version allows you to upload both PDF and TXT. And then once it's uploaded, it will be put into the vector database and for searching and indexing. And then I can ask questions around it. So I haven't tried with very large file, but small files definitely works. Yeah.
Thank you.
Yeah, thanks. Well, thank you so much for attending. Really appreciate it, your time.